Hey guys, today I'll be solving lead code number 875, Koko eating bananas. It is a medium question on lead code. Now this is the most infamous binary search question. If you don't know about binary search, then I would suggest watching or like doing easier lead code questions. I have a couple of them on my channel as well. But in this implementation or like answer explanation, I'll be focusing on what we are tracking and not more so of what binary search is, because I'm assuming that you know it if given that you're trying to attempt this question. This question doesn't look like binary search at first. You wouldn't guess it because but the pulse given is not sorted. First of all, there's nothing about sorting in this entire question, nor is there anything about looking up middle values. But the thing that comes up actually is the fact that the best possible way to determine the minimum eating rate, essentially, that's what we have to determine. So if we determine like a lower and upper bound as to what the best eating rate is, like the lowest could be 1, right? The lowest is 1 because you realistically can't have 0 as your rate, because then you don't eat any bananas. So your lowest would be 1, right? And your highest, right? Your highest would be the highest in the array. That's the whole premise of the question, I would say. The highest rate that you can get is essentially the highest in the array, because if you eat the highest in the array within an hour, then every other element inside of the array can be eaten in less than that hour. So let's say if you have 25 bananas and you have one banana in your array, it's written as 1 and 25. If you pick your eating rate to be 25 in this case, you can eat that one banana in that 25 rate, right? Obviously you can, and you would eat that 25 as well in that 1 hour. So that is the whole premise of this question, determining the maximum value that you can get for your eating rate and the lowest value being 1. So after that, all you have to do is figuring out the most optimal minimum eating rate, right? And since you already have a lower and a higher bound, then obviously you have to do a binary search. So that's pretty much it. That's the whole explanation for this question. If you want to write out an answer before I go into the solution, go ahead, feel free to do that. But that's pretty much it for this question. So if I start writing it out, if we consider our maximum, so let's say left is 1 in this scenario and our right will be our max k, okay, our maximum eating rate. So all we have to do first is get the maximum number, right? So if you just do for num in pulse, if num is greater than right, then just keep that as our maximum, right? So by the end of this loop, our right will be pointing to the maximum k. So now we have this array. We have this basic array that goes like 1, 2, 3, 4 all the way up to k, okay? And we're supposed to do a binary search on this. Now given that that is the lowest part, so like I've written already, left is equals to 1. I'll just write it down again. Left is equals to 1. Our result, okay, so we'll hold this variable inside the result, because you can't return as soon as you hit your answer. That's wrong. If you return as soon as you hit your answer, as in like return mid when you find the element that fixes this, that reaches the solution, that's not the best possible answer, right? That's the, you could consider that as the maximum of the best answer, right? That's what you would consider it as first. You wouldn't consider it the most minimum, right? So that's why you have your result first. You would store it as right, because if everything goes wrong, your right is the maximum rate that you can eat at, right? So that's definite. But yes, besides that, like I said, don't hit immediate return when you have the answer, because you want to minimize that section of the array once you get that, right? So if you do middle as L plus R by 2, I'll stop writing left and right because it gets tiring. I'll just do L plus R, plus there's going to be too much clutter. Total equals to 0. Now total equals to 0, why? I didn't explain this. Okay, so total equals to 0. What we have to do for each rate that we pick, right? We have a constraint that we have to eat it in. I'll just take the first example right here, 3, 6, 7, 11, right? And our constraint is that we must eat it in 8 hours. So if we spend 1 hour eating one pal, then we would have 8 pals doing that. But in this scenario, we are given 4 elements and we have to finish them in 8 hours. Okay, so if we consider our right already, our 11, that's the maximum, right? If we consider our 11, what is the rate that we would eat 3 at, right? What is the rate we would eat 3 at? And that's simply just 3 by 11 ceiling, not floor, ceiling, right? You would do floor if you were looking for the other way around. You would do ceiling because you want to see the maximum amount of time it would take for you to eat it. So 3 by 11, it will give you something 0 point something, right? So that would be 1. It would take you an hour, right? Because it takes you 11 hours to eat a banana. 1 hour to eat 11 bananas. If you take 3 bananas, then obviously it will take you less than 1 hour. So the same for 6 as well. It will give you 1. 7 as well, it will give you 1. And your 11 as is would just give you 1 as well, right? And if we add these hours over here, we get 4, right? And 4 is obviously less than or equal to 8, which is really good, right? It is a good answer. It is a very good answer actually. But is this the best that we can do? Is 11 the minimum rate that we can eat at to satisfy this requirement? Well, no, obviously, because the answer over here is 4. And essentially what this binary search that I'm going to do will do is, we have left as 1, we have right as 11, and we will find the middle always. So 11 plus 1 by 2, this will be 12, 6, right? So we would try 6, then we would see 3 by 6, 6 by 6, 7 by 6, 11 by 6. Then we would add them and we will see if that is less than or equal to ours. If yes, okay, we are happy. We will still try to minimize the 6. So our new constraint would now be 1 to 6, because we want to minimize it, right? We want to minimize the k. So 1 to 6 would be our new constraint. We want to see if there's a number 1 through 6 that can do it as well. So our new constraint with that, we would be 6, 1 divided by 2, 3, right? Now we would check 3. We would see 3 by 3, that's fine. 6 by 3, that gives us 2. 7 by 3, that gives us 2.5, which turns to 3. Sorry, I'll just show this out. 11 and 3. So this would give us 1, this would give us 2, this would give us 3. 11 by 3, 9, 3 point something, so 4. 1 plus 2 plus 3 plus 4, so 10, which would not satisfy the 8, right? That would not be satisfied. So we can't go with 3. 3 is the place where if we went any lower than 3, it wouldn't matter what our number is. We essentially just can't pick our rate to be 3 because it doesn't satisfy the requirement. So now our new one would be 4 to 6, and we would do 4 plus 6 by 2. We would pick 5, then we would do the same for 5, and for 5 we would see that actually it works. Then we would minimize for 5 as well, so our new range would end up being 4 to 5, right? I'm assuming you know binary search now, because I won't be writing it out completely. I just want you to already think of binary search in your head. And then 4 to 5, we would see 4 to 5, 4 plus 5, 9 by 2, we would end up getting 4, and we would check 4. It would work, and 4 would be the last exit we would have essentially. Okay, so when I do total equals to 0, what I'm going to do in that is all I'm going to do is add up the amount of hours it would take to run through the pal. So for num and pals, total plus equals to math.ceil, again ceiling, by the way, ceiling, because that's what you need. You want to pick out the longest amount of time it would take for you to eat the pal. Okay, this is going to get in the way. I'll just remove that. Yep, and now the condition, like I said, if total is greater than high, the thing that we did with 3, well, we don't consider it anymore, right? So we will just move our entire array to look at the numbers ahead of 3. But if we are inside of the condition that makes it valid, we will store the answer that we are at right now, because we will be happy to take that if anything goes wrong, and we will try to minimize it though. We will always try to minimize it. Alright, and at the end, like I said, we will never return mid or anything like that. At the end, just return your result, because that already keeps a track of the mid. And that's it for this question. If I removed I'll remove this. If you needed to look at the explanation, just rewind a little bit. I'll just do this so that the code itself is a bit clearer. So yep, get your maximum, right? Get your maximum over here, and then you perform your binary search. You check how much hour the time it takes, hours,